So now we are going to look at the solutions of assignment number 2. So first of all, we have question number 1 and we will look at its solution. So question number 1, in the question number 1, we have to convert an octal number into hexadecimal. And the number is 27.3 in octal and we have to convert it into hexadecimal. Now we know that octal into hexadecimal conversion is not direct. So first of all, we will convert octal into binary on this slide, and in the next slide we will convert binary into hexadecimal. So this is the part A, and in that we are going to convert the octal number into binary. So here we have the number 27.3. First of all, we will look at the letter 2 and we will look into the table. So 2 is equal to 0, 1, 0 in binary. So we write here 0, 1, 0. Next we have the letter 7 and here we can find 7, and 7 is equal to 1, 1, 1 in binary. So we write 1, 1, 1. Next we have the floating point number and then we have the digit 3. So where is 3 in the table? Here is 3. And 3 is equal to 0, 1, 1 in binary. So we write 3 as 0, 1, 1. So now we have calculated, we will combine this value and this value to make the final answer. So now we can say that the number 27.3 in octal is equal to 0, 1, 0, 111.011 in binary. And in the next slide, we will convert it into hexadecimal. So this is the part B of the question, and in that we will convert this number into hexadecimal. So here we write the number in the form of groups. Each group contains 4 bits and we will make the groups while moving away from the decimal point. Okay. So first of all, we make group of 1, 1, 1, 0. So here is 1, 1, 1, 0. So this group has 4 bits. Next, only 1, 0 is left here. So we know that we need to make group of 4 bits. So we will add 2 zeros here to make it a 4-bit number. And next we see towards the right side of the decimal point that we have the number 0, 1, 1. Again it has 3 digits, we need to make it 4. So we add 1 0 to it. So now we have made the groups. Next we will look at the table and find its equivalent hexadecimal value. So first of all, we look at 0, 0, 0, 1, which is where? Here in the table, and it is equal to 1. So we write 1 here. Next we have 0, 1, 1, 1. So in the table, we can find 0, 1, 1, 1 here, which is equal to 7. So we write 7 here. And in the last one, we have 0, 1, 1, 0. And if we look at 0, 1, 1, 0 in the table, here is 0, 1, 1, 0 in the table, and 0, 1, 1, 0 is equal to 6. So we write 6 here. Now there is some mistake of the errors. Please don't consider them. Just consider what I am writing with my pen. So now we have calculated the number, and now we can say that this binary number is equal to 17.6 in hexadecimal. And we can also say that the number 27.3 in octal is equal to 17.6 in hexadecimal, as we converted this octal number into binary first and then this binary number into this hexadecimal number. Okay, next we move to the solution of question number 2. So here we have to convert a hexadecimal number into octal. And we know that when we are going to convert hexadecimal into octal, then first of all, we will convert hexadecimal into binary and then this binary into octal. So here is the part A. First of all, we will convert hexadecimal into binary first. Okay. So we have the number 2f.9 here. So we will look at the table. Where is 2 in the table? Here is 2 in the table, and it is equal to 0, 0, 1, 0. So we write here 0, 0, 1, 0. Next we have the digit f, and we will go to the digit f in the table, and f is equal to 1, 1, 1, 1. So we write it here. Next we have the digit 9. So here is 9 in the table and 9 is equal to 1001. So we write here 1001. Now we will combine this value and this value to calculate our final answer. So now we can write here 00101111.1001. Okay. So now we can say that the number 2f.9 in hexadecimal is equal to this number in binary. While calculating the final answer, we have omitted these 2 zeros. They are extra. You can add them, and if you don't add them, still the value of the number will remain the same. Okay. Now in the next part B, we are going to convert this binary number into octal number. Okay. So we are going to make the groups of this binary number, and each group has 3 bits while moving away from the decimal point. So first of all, we will move towards the left side of the decimal point. First of all, we have 111, so we write here 111. Next we have 101, so we write here 101. And then we have, while moving towards the right side of the decimal point, we have the number 100, so we write here 100. And then we have the number 1, so we write here 1. So we need to make group of 3 bits, so we add 2 zeros to that. Alright. So now we have completed the groups, and we will look at the table and find out their octal equivalent. So first of all, we have 101. Where is 101 in the table? Here is 101 and it's equal to 5, so we write 5 here. Next we have 111. So here is 111 in the table and it is equal to 7. So we write 7 here. Next we have 100. So here is 100 and it is equal to 4. So we write 4 here. And again we have 100. So here is 100. So we can write 4 again. Next we will combine this value to calculate our final answer, that is 57.44. So this binary number is equal to 57.44 in octal, or in other words we can say that the number 2f.9 in hexadecimal is equal to 57.44 in octal. So as we know that first of all we converted this hex number into binary and then binary number into this octal number. Next we move to question number 3 solution, and here we have to convert our decimal number into binary. So we can see that we have to convert a decimal number 67 and we have to convert it into binary. So first of all we will place it here and we will divide 67 by 2. So we can see that the quotient is 33 and remainder is 1. Next 33 is divided by 2 and then quotient is equal to 16 and remainder is equal to 1. Next 16 is divided by 2, so quotient is equal to 8 and remainder is equal to 0. Next again we divide, so quotient is equal to 4 and remainder equal to 0. Then again 4 divided by 2, quotient is equal to 2, remainder is equal to 0. When we divide 2 by 2, so we have the quotient is equal to 1 and remainder is equal to 0. So now we will calculate the value while moving like this from bottom till top. So we will calculate the answer like 1, 0, 0, 0, 0, 1, 1. So as you can see that the answer is 1, 0, 0, 0, 0, 1, 1 in binary. So this is how we can convert the decimal number 67 into this binary number. Next we have question number 4, and in this question we have to convert the decimal number into octal number, right? So we are given with the number 652 in decimal and we have to convert it into an octal number. As we have to convert it into octal, so we will divide the number by 8. So quotient is equal to 81, remainder is equal to 4. Again 81 is divided by 8, so quotient is equal to 10, remainder is equal to 1. So again 10 is divided by 8, so quotient is equal to 1 and remainder is equal to 2. And again we will calculate the answer by moving like this from the bottom till the top. So the answer is 1, 2, 1, 4 in octal. So now we can say that the number 652 in decimal is equal to 1214 in octal. So this is how we can solve question number 4. Next we move to question number 5. And here we have to convert a decimal number into hexadecimal. So the decimal number given is 55 and we have to convert it into hexadecimal. As we have to convert it into hexadecimal, so we will divide 55 by 16. So when we divide it, quotient is equal to 3 and remainder is equal to 7. As 3 is smaller than 16, so 3 cannot be divided by 16 again, and we will stop the process. And we will calculate the answer by moving from bottom till top like that. So here we can say that the answer is 37, or you can say 37. So the number 55 in decimal is equal to 37 in hexadecimal. So this is how we can convert it.